Sorry about that. Sometimes Zoom just crashes so badly that the video just ends, and so I have a break there. Sorry about that. So anyways, we were trying to work on section 9.3 about the quadratic formula. We were trying to start this example about a squared minus 2a equals 15. As I was saying, my first step would be to collect um, non-zero terms onto the left side. And on this one, I think it might factor, so I think I will just do that. So if so, we're looking for two numbers that multiply to negative 15 and add to negative 2. That's going to be negative 5 and positive 3, right? So double check by multiplying if you want. So we'd have a squared plus 3a minus 5a would give the negative 2a and then minus 15. So this would give us solutions of 5 and negative 3. And that's the end of it. So as you can see, when it does factor, it is faster. So I would always try to look and see if a equation can be solved by factoring the one side rather than just automatically jumping straight into the quadratic formula. If you really want to see it, here's how the start would look, setup would look for the quadratic formula. So here we'd have minus b, so that would be 2, plus or minus the square root of b squared, that's 4, minus 4 times. Here, don't be put off by the fact that the variable is in a rather than an x. Our coefficient of the squared term, which is what we would think of as a, is actually 1. And then our c here is going to be negative 15. Okay, and then that's all over 2 times 1. Okay, so I'll leave it to you to check that out. It's going to give you the 5 and negative 3 that we expect. All right, so now let's try one more by the quadratic formula. So for this one, it's wise, and it's okay. We'll have minus 12, that's our b, plus or minus the square root of b squared, 12 squared is 144, minus 4 times 3 times 7, and then that's all over 2 times 3, or 6. Okay, so let's neaten that up slightly. All right, so now I'm going to need to calculate this radicand. 144 and that looks like 84, right? That's worse. So we have the square root of 60, and then that's over 6. So then 60, that's going to be 15 times 4. So we'll have negative 12 plus or minus 2 root 15, and that's over 6. And then here we can separate that into two terms. So we'll make that negative 12 sixths plus or minus 2 over 6. All right, so this will give us negative 2 plus or minus root 15 over 3. Okay, and so there is that. If you want to keep this with a common denominator, you can. This would be negative 6 plus or minus root 15 over 3, all over 3, if you so chose. All right, that's the end of that. We have just a few more examples. In the next one, we have 4x squared minus 2x plus 8 equals 0. On this one, you'll notice that the all three terms have 2 as a common factor. So I would here begin by dividing by 2, just to make the numbers a little smaller. We'll have 2x squared minus x minus 4, 0. And as you saw or have seen with the quadratic formula, you're squaring and multiplying. Sometimes the numbers can get kind of large. So I would definitely take an opportunity to scale those numbers down wherever possible. So here, the whole equation, we were able to divide through by 2. Okay, so now x will be minus b, so that's 2, plus or minus the square root of b squared minus 4 times a times c. And that's over 2 times a. Okay, I think, let me double check that. So I was reading the blue one. So b squared, that's 4 minus 4 times a times c. Okay, better. All right, 2 plus or minus. And then in the radical, we have 8 times 4 is 32. That's positive 36, it looks like. The square root of 36 is just going to be 6, isn't it? So we'll have 2 plus or minus 6 over 4. 2 plus 6 is 8. 2 minus 6 is -4. So this will give us 2 and -1. So once again, here's one that would have factored if I had tried. Okay, let's try another one. This time we have fractions in it. As we've seen before, when you have an equation with fractions in it, one thing that you can do is multiply by the LCD of the fractions to eliminate those fractions. So the smallest multiple of 4, 3, and 12 is going to be 12. We're going to multiply the whole equation by 12. And that will serve to eliminate those fractions. Okay, so 1/4 of 12 is going to be 3. 1/3 of 12 is going to be 4. Okay, 1/12 times 1 is going to be 1/12 times 12 is going to be 1. All right, so then once again, let's collect everything onto the left-hand side so that it's set equal to 0. So from here, pause the video and try this one yourself, and then restart the video and see how you do. All right, so going through the details on this one, the quadratic formula ends up giving us 2 plus or minus the square root of 7/3, and the steps are here shown. Okay. Sometimes we're interested in the nature of the solutions without necessarily wanting to know or needing to know what those solutions are actually. And so in that case, using the discriminant is helpful. The discriminant is the part of the quadratic formula that is underneath the root sign, that is the radicand. So that's the b squared minus 4ac part. That's known as the discriminant. We can use it to help us describe what the roots or solutions are going to be like. So let's think on it for a minute. If b squared minus 4ac is equal to 0, say, if that were equal to 0, then the whole radical would be gone, and you would have plus or minus 0. So the solution would just be minus b over 2a. So you'd have one solution if the radicand were 0. If it were a perfect square, we would have rational number solutions, as we've seen. And if it were negative, we'd have complex number solutions. So here's some examples. For this, we have 3 quadratic equations. We're going to just use the discriminant to decide what the solutions will be like. Okay, so for this first one, we're going to find b squared minus 4ac. Here, b squared is 9 minus 4 times 8 times 6, and that's negative. So we'd have 2 complex solutions. That's with the I in them. Okay, let's try the next one. For 5y squared plus 6y minus 2 is 0. B squared is going to be 36. Then we have minus 4 times 5 times -2. Okay, so that's going to be 20 times 2 is 40. So this would give us 76. So this would give us 2 irrational solutions. (76) is not a perfect square, so we would end up with irrational solutions. Okay, for this one, b squared, that will be 24 squared. We'll do that in a minute. Minus 4 times 9 times 16. Okay, so let's calculate what that is. All right, so this one ended up with a discriminant that was 0, so this would give us one solution.